Let me do one quick addition after we fixed the problem just now. Let's do a quick performance comparison. So first, we'll see how a type function performs, and we call the tool Hyperfine. Hyperfine minus I. That is obviously wrong because we gotta run the whole thing. And now if we look at this, Hyperfine tells us that this DMD invocation takes about 58 milliseconds, and that one is, let me quickly look at what this one even is. I think this one is the type function, so, and that was yeah, and by the way, that's using a debug build and writing all this output. That was 58 milliseconds, right? Yes, and we can reproduce that. It's like 58 milliseconds. Let's be generous. Let's say type function is 60 milliseconds. Type function 60 ms. Yeah, and remember that type function is producing a lot of output, so that's also something you pay for. Now let's check. Well, and the type function actually gives you the member names. Let's now check how the template performs. For that we have to do a minor modification. It is really quite minor. We gotta include the version TMP, and we have to add another set of braces here. That's it. And we only get F's because semantic of type function and templates are slightly different. And we'll see what Hyperfine says, how long this takes. And it takes 63 milliseconds. So it doesn't take that much longer in time. Though it takes a little bit longer, although it does less. Well, although the output is less useful. Let's now use the time utility to look at what the memory consumption could be. It's usability time. Let's look at what the memory consumption could be. Alright. Okay. Yeah, I have to remove this. Let's look at the memory consumption. This is 20 megs. And the other one is also 20 megs, a little bit less. So we have established that. Oh, and I'm not sure if we tested this with, I think we tested this with concatenate equals. So what we have established is that the template takes a little bit more memory and it uses a little bit more time. Okay, that's fine. Let the template also give us a red identifier. For that we do tuple of I. Or I think we can do member tuple I. That might be a possibility that this gives us the right output. It does not. Member tuple cannot be read at compile time. Right. This has to be a template. The template version. And that gives us an interesting output, but not but it does not give us the output we would have wanted. So yeah. But again, if we look at the actual time difference at those scales, it almost doesn't matter. Oops, non-zero execute. What did it do? That. Oh yeah, it can't read the number tuple of either. That's weird. It's actually weird that it can't read that. That seems to imply that we are currently doing something weird. We are definitely currently doing something that is not a good idea, because like it seems like this member tuple is visible in there. Oh, we had the version template still on. So yeah. Oops. Still cannot resolve to init. Oh yeah, because we didn't use the template, we used the type function. And type functions, so I can't do that. And we see that the template version runs consistently slower than the type function. That is not surprising, and the difference doesn't seem like a big deal right now, but at scale it is a big difference. And again, not to put too fine a point on it, but the memory consumption is also slightly higher with the template version, and we haven't even used recursive templates yet. Like, this is just a tuple expansion in the tuple for each that doesn't happen in type functions. Okay, that's it.